Hey kids, it's Miss Talent. So we are going to go over our new unit, which is over energy. And so lots of y'all have done a great job on your sound packet and your ringtone project. So keep up the great work. But if you were not done, just keep in mind now we're moving on to the energy unit, and I just don't want you to get confused. So we're on week 3 based on your Canvas modules. And if you have the hard copy, we're now on to the energy unit packet. And you are going to write these into your journal so you have them. These are the handwritten notes just like we would do in class. And so I'm going to go over all of them today, and then there'll be videos throughout the week from all three of us, Miss Henson, Coach Vondenstein, and I, about how the energy transfers, different types of resources, and things like that. So be looking out on YouTube for those as well. And so I'm going to zoom in, and we're going to just go in order. You should have these on a PDF as well into your module. They're called the handwritten notes, and just to make sure so you can write them. I'm not going to pace myself to let you write while you watch, so just make sure if you need the hard copy, it's already available on Canvas as well. So 11.1, how do we use energy? So we use energy on a daily basis. We actually are not using probably as much right now given the pandemic, but we do use a lot of it. And things that we don't think about. We think about our lights, our computers, our cell phones, our cars, how to turn on the lights at the school, things like that that impact us every day. But things that we use are also built in factories, so industry, transportation on a bigger spectrum, such as airplanes, trains. And then we use them, of course, at home and offices, which is what we come in contact more with. Energy consumption varies throughout the world, so we are actually the leading country on energy consumption. So we use a lot, China uses a lot, and Europe uses a lot. So we're all up there in the top 3 or 4, and so based on that, it's a lot to do with our population as well. So keep that in mind. Now, there's two types of resources we use to create energy. There's one called renewable, and then there's one called non-renewable. And fossil fuels is a non-renewable resource. So it's anything that we can obtain energy from as a resource, but fossil fuels are a non-renewable resource. And what it is it stores chemical energy, and as it's burned, then it is actually creates the energy, and the energy is released. So, for example, coal. When we burn coal, it produces heat, which then we turn into electricity. Natural gas, oil, things like that. Oil is one that we put in our car. Of course, it's turned into gasoline, but it is based off of that. So we use different things, and they're burned through the engines or the actual devices to create the energy. So fossil fuels are the most common used, and they're only found underground, actually. We're going to move on to 11.3, renewable and non-renewable. So I kind of already hit this a little bit, but only 1/8 of our energy comes from renewable resources. Renewable resources are ones that we cannot use up, but we can, and the world actually, like the earth actually naturally replaces it itself. So we do not use enough of this. If you realize, I'm sure you do, we're trying to use more renewable resources, but so many things that we use on a daily basis are already built to use the electricity that comes into our homes and things like that, and the amount that we're using. So renewable is wind. Hydro, which would be water, like for example, the Tennessee Dam at Pickwick, that is actually a hydro dam that produces electricity. Actually, it might not be one that produces electricity. Some dams are really used just to actually monitor the water flow, but there are dams around that are actually used for electricity, solar, and biofuels. Then there's the non-renewable, which we've already hit, which are mostly fossil fuels, oil, coal, nuclear, and then natural gas. So when we next week on week 4, you're going to actually pick one of these, and you are going to do a project, and you're going to answer some questions about it. You can make a Google slide, you can make a PowerPoint slide, you can make a keynote, you can make a video, you can make a collage, just like a PDF collage of things. You can make a collage at home that doesn't require any technology. So you're going to get to pick one of these, and I want you to pick one that you're maybe not as familiar with that you want to learn about. So these would be the resources that you're picking from for your project. Now, just like in class, I would tell you this is the first part of our unit, so learning about our resources, and now we're going to go to the second part of our unit, which would be how heat is transferred. And there are 4 ways that heat is transferred. Conduction, convection, radiation, and evaporation, which is on another set of notes. So there are 4 ways that heat is transferred. Now this was supposed to be a foldable, so I'm going to go over, I'll flip the page, but I'll tell you what each one's about. So I'm going to go over here and zoom in. Alright, so here we go, heat transfer. This is just explain how heat transfers. So energy or heat transferring is all the same thing because energy is heat, heat is energy. So how energy moves from one form to another. So heat flows from a warmer substance to a cooler until the temperature is equalized. So for example, heat rises because it's trying to get out. Okay, our basements are cold because the heat is rising. Our heat tends to flow. So if we used a diagram with like little water, like air molecules, heat will overtake the colder to balance it out. The next one is conduction. These 2 are about conduction. So this is the definition and this is an example just to help you out with your notes. So conduction is where the transfer of heat from a warmer substance to a cooler substance through direct contact. A prime example of this is you making pasta and you take a metal pot and you put it on the metal stove. And I know like we have gas stoves, we have electric stoves, it doesn't matter. You are putting it on an actual eye that is metal to metal, so it's direct contact, and then it heats up the pot. Remember, the pot is cold to start, colder than what the eye is. So that would be direct contact. The next one is convection. So this happens all the time out in nature. So we have convection currents in the ocean. We have convection currents in the air that makes our weather. When we boil water, we're making convection currents. So anything that has a current is going to be convection. So it tends to be through liquid and gas only. And like I said, we have convection currents that are heating, for example, in the mantle of our earth. And we also have it in the weather. And when waves break in the ocean, it's because the convection current of the wave is being broken. Okay, and so these things are occurring all the time. The next one is radiation. So the transfer of heat as an electromagnetic wave. Magnetic wave. So this can occur in an empty space. So heat just in general from radiation. So a really good example of this would be, I'm trying to think of the sun's heat, earth through the, so like, yes, the sun is heating the earth. That's a prime example. It's traveling through space, the heat of the sun, and it's warming us. A really good example of radiation would be if you were at a bonfire and you put out your hands and you feel that heat, that is radiation. So that might be a more realistic example for you all. So those are the first 3. So we have conduction, convection, and radiation. And now we're going to move on to evaporation, which you're probably thinking, how is evaporation a transfer of heat? It's actually evaporation. We kind of always envision that with the or the water molecules coming off the grass, or we think of we just kind of don't associate it with, we think it's warming up and coming off the leaf, like it's evaporating. And that is what's happening, but it's actually not boiling the leaf to get the water off the leaf. Evaporation is actually where the temperature is low and the water turns into water vapor. So let me kind of explain that because I think it's really hard to explain. So, or understand. So evaporation cools you down. So how many of you have ever jumped into the pool, right? And then when you get out, you kind of get a little cold, right? So the reason you're getting a little cold is because the water's evaporating off of you. The water evaporates and it takes the energy from you, therefore giving you a cooling effect. So I think it's still really hard to understand. So you know me with my little pictures. Y'all don't make fun of them. But here is the idea, okay? So here's particles with less energy left behind, okay? So here's like say like the blade of grass, okay? And so all of these particles are escaping that have all this energy or heat, right? So it has all this energy and it's escaping off of you as you dry off from the pool. Well, then you are left behind with just the drops that have low temperature, so it's going to have a cooling effect. So we envision evaporation as like heat induced, which it does. I know the sun might have something to do with the water droplets gaining the energy, but actually the grass is cooling off after the dew gets risen off of the grass. And so it's a very interesting concept, and if you need help on your unit packet on this section, I know it's hard to understand, but what's left behind is a cooling effect. And what is taken off of you that's actually being evaporated has the heat or the energy. And so it's a little different. So those are your four. Ways energy or heat can transfer is conduction, convection, radiation, and evaporation. So let's do a little quick review one more time. We have our resources. We have renewable, which the earth replenishes. We have non-renewable that we are using up too fast, and they're normally found underground, and they're called fossil fuels. We have our four types of energy transfer: conduction, convection, radiation, and evaporation. And you do need to understand that conduction is direct contact, convection is through currents, radiation is through electromagnetic waves, and then evaporation is technically not boiling and it has a cooling effect. And it's where water turns into water vapor. So I hope that kind of helps break it down to make it a little easier. Remember, these are your definitions and these are your examples when you write your notes. And if you have any questions, you can reach out to your teacher. But we certainly miss you all, and we're hoping we're back together soon. Talk to you all soon. Miss you all.